they're using pi as a symbol for the angle, not for the number. So please, let's reserve pi for the number. Theta and phi are the angles that I use the most. That's a phi, and theta, lowercase. All right, so I have a triangle there, 3, 4, 5 triangle. So if that's 3, let's keep the same, 4, 3, and 5, and I'm trying to find this angle right here. If I went to a larger version of it, so 8, 6, 10, is this angle the same as that or different than that?
This is the same.
All right, I heard same. I don't know if anyone's said something different. Were you the same? Okay. So as long as I've got the same ratios here, I'm going to have the same angle. If only there were math that could handle that. How many of you have had trig? A couple people, and some people just not wanting to admit it very rapidly. All right, we will be using right triangle trig in here. For those of you who have had trig and you've dealt with law of sines, law of cosines, it's great if you can use them, but I'm going to try to stay away from law of sines, law of cosines. So for those who haven't had trig before, let's talk about trig. So when we're talking about this, the ratio of sides, so I've got this adjacent side here. So if I'm in a room with 3 walls to it, and I'm standing in the corner, I can touch 2 walls. I can touch one of these 2 walls, I can't touch that one. This is what's considered the opposite. So if that's my angle, this is the opposite. This is called the hypotenuse, which I hope is not a shock to you. And this is referred to as the adjacent. So I have 3 basic ratios. I can flip any of them upside down, but 3 basic ratios. I've got this adjacent divided by the hypotenuse. I have the opposite divided by the hypotenuse. And then I have the opposite divided by the adjacent. Those are basically the 3 ratios that I can do with this triangle. And if you want, you can take the reciprocal of any of them, but these are the 3 main ones. If I take the adjacent over the hypotenuse, which in this case is 0.8, that is equal to what is known as the cosine of the angle. So when you say cosine of the angle, all it's saying is that for that right triangle, the length of the adjacent side over the length of the hypotenuse is a set ratio. This would be 0.6. This is known as the sine of theta. And for those who are not familiar with trig, cosine spelled out and sine spelled out. And then opposite over the adjacent, which is 0.75, is equal to the tangent of theta. All right, as solving for any unknown, you need to get rid of all the stuff hanging on. So if I want to solve for theta, I need to get rid of that cosine. Well, I can't divide by cosine, they're attached. It's not like, it's not multiplication going on here. There's this function which is graphs on, so we have to somehow undo it. And the way you undo it is with the inverse function. So if I do the inverse function, I have to do it to both sides. So the inverse function, also known as the arc cosine, and it helps if I actually spell it right. So the arc cosine, so it's just the word arc in front of it, of 0.8 is equal to the arc cosine of the cosine of theta. Arc cosine and cosine cancel each other out, they neutralize each other. So I'm left with theta on the right-hand side, and on the left-hand side, I'm left with the arc cosine of 0.8. That's supposed to be an 8, but apparently it's been beheaded. On your calculator, most of you will have a TI something. Anyone not have a TI? Texas Instrument? What do you have?
I'm working on getting one right now.
Okay. Personally, I don't use a TI, so there'll be certain functions where I'm going, I know I can do it, I've seen students do it, but I don't know how to do it on your calculator. I have an HP. So much faster than having to type everything out like that. All right, so on your calculator, it's going to be cosine with a -1 theta, wrong, of 0.8 is equal to theta for most of your calculators. On my calculator, it's ACOS, 8 cosine 0.8, and I will tend to write it this way. So there's 3 different ways that you might see it. I'm really not fond of this notation because something raised to the -1 is a reciprocal, and this is not a reciprocal, it's an inverse function. But I do accept that a lot of your calculators will have that notation. So, if you do the arc cosine of 0.8, you get
36.87.
So we want to finish it up for him?
Degrees.
Yeah. Don't forget units. Especially with angles. If you don't put a unit down, it's assumed radians. If you don't know what a radian is, just wait, we'll get there. If you also did the arc sine, so the arc sine of 0.6, you better get the same thing. And the arc tan of 0.75 should be the same thing. And if you're getting something different, you might want to check to see if you're in radians or degrees. Questions to hear? All right, so back to our original problem. So in polar form, this same thing would be 5 kilometers. There's my magnitude, and my direction is 37 degrees. These are the same vector, just 2 different forms. Let's do the same problem, but backwards. I have a force that is 7 newtons at a 40-degree angle. From the typical math point of view, that is pointing up and right. So if I just sketch it out briefly, it's going to be pointing sort of in that angle right there. Now, when I draw angles, they all seem to look like 45-degree angles. So we'll go with the classic, not to scale. And what I want to figure out is how far to the left and how far up do I need to go? Well, first off, I'm going to define my directions because I don't feel like writing right and left, so I'll just do my I hat and J hat. If you have difficulty telling the differences between my I's and J's, my I's curl to the right, my J's curl to the left. So I'm trying to figure out this and that. I know this is 7 newtons, and that angle is 40 degrees. I'm just going to label this one A and this one O. For adjacent and opposite. I know that the tangent of 40 degrees is the opposite divided by the adjacent. That's not really going to help me since I don't know either of them. The cosine of 40 degrees is equal to my adjacent divided by my hypotenuse. And the sine of 40 degrees is equal to the opposite. The opposite over the hypotenuse. So I would recommend using one of these two. So A, my adjacent side, is going to be equal to 7 newtons times the cosine of 40 degrees. Which is, someone be kind enough? .36. Heard somebody say it, I think. Yep. My opposite side. Well, I'm doing it from this one. I actually could use that one also, but this one's simpler. The math problem is 7 times the sine of 40 degrees. You don't have to write the units in the middle of the problem, just make sure that they're at the end. Unless you want to do some bizarre units.
4.5 newtons.
Just 4.5?
Newtons.
All right. So this in polar form, is that. In rectangular form, it is 5.36 newtons to the right, which I said was I hat, plus 5 point, that's what I just did. 4.5 newtons J hat. That is in rectangular form. I could have also written this answer. I'm first going to write it incorrectly, just because I've seen it so many times. I'm going to first hit that, plus 4.5 J hat newtons. I've seen it like this. This is not proper, because if you do it this way, then newtons is associated only with the second term. You want to just write the units once, that do need parentheses around it to indicate that it goes with both of them. Just looking at this and thinking of the actual physics that we'll eventually get to. That's probably enough for now. Course entry assignment, don't forget that. The due dates that are in the syllabus, ignore. I had to put something down. I don't know how teachers in general put down due dates without knowing the makeup of the class and how fast you can go, but apparently it works quite well for some people, but not for me. So due dates will be announced as we go. I think in Blackboard also I had, did I put the due dates? I don't know if I put the due dates in there in Blackboard or not. There's quite possibly a mismatch between what I put into Blackboard in terms of due dates and what's on the syllabus, just because I knew them all, they were all going to change. So I didn't put much effort into that. For tomorrow, do expect you to have printed out the graphing lab and have done the pre-lab, which is the last page. And I think on that note, see you tomorrow.
Do you want me to turn off your recording?
Oh, yes, please.